Hello, welcome to the Rotary Contour Multi-Axis CAM Strategy Lecture by Todd Frazee of Sierra College. This lesson focuses on the Rotary Contour Multi-Axis CAM strategy in Fusion. It's a powerful tool for complex geometries on cylindrical or conical parts. The Rotary Contour strategy allows you to create precise toolpaths that follow the contour of your workpiece as it rotates, following a cylindrical axis. This makes it ideal for the machining of features such as intricate patterns on round surfaces. The objectives of this lesson are that by the end of this lesson, you'll be able to apply the Fusion Multi-Axis tab to apply the rotary contour strategy to machine cylindrical shapes in 4-axis and 5-axis setups, to model CAM in 5-axis CNC mill applications to industry standards, and to apply CAM in 5-axis CNC mill applications to industry standards. There are 3 rotary multi-axis CAM strategies, the first being rotary pocket, the second rotary parallel, and the third rotary contour. They're all found under the multi-axis tab in Fusion. Setup for all the rotary multi-axis CAM strategies are very similar, if not almost the same. They must be aligned with the rotary axis motion of the rotary axis machine. And material removal volume is defined by front and back ends in the geometry tab, and diameters on the radii tab, with the rotary contour and rotary pocket requiring inside and outside diameters to be defined, and for rotary parallel only requiring an outside diameter to be defined. The rotary contour strategy is a finishing operation used to machine steep walls on rotary parts. Parts with spiral walls, such as extruder screws, can be machined with this strategy. And the minimum final cutting radius parameter defines the amount of material to remove at the final step down. There are different options, some on the Geometry tab and some on the Passes tab, that are different for this command compared to others in the rotary selection area. We have the Geometry tab. You have a fixed tilt for cone machining, and if you check that box, you can enter an angle of a cone. Now, to do this, you have to have either your rotary 4th axis set up at an angle, or you're using a 5-axis where the tilt axis tilts to an angle, and then you can rotary machine a cone shape. And there's also automatic step down checkbox to remove material effectively with step downs if you're going to remove a lot of material. And it allows you to put in a minimum step down step and a maximum, and it will cut between those two ranges. You can also select step down on floors to make sure that it finishes the last bit of geometry if it doesn't fit within the minimum and maximum steps that are generated. We also have an option to exclude small areas that the tool diameter, you can put a threshold of what size cutter will go down into the space. Perhaps you intend to go back with a smaller cutter to clean up that area. And lastly, you have a machine over gaps checkbox, and that machines over small gaps instead of performing linking moves for quicker machining. So that'd be like retracts up to the retract plane. It'll generate a code that goes in a G01 or feed rate mode over that feature. Okay, now let's look at a demonstration of applying the Rotary Contour Multi-Axis CAM strategy in an example in Fusion. Okay, we're going to stick with the default tool. We're going to go to Geometry tab. It defaults to a disk that's normal to the Z-axis of the cutter. what we want to do is change that rotary axis orientation. We're going to select on orientation, and we're going to do it in reference to the rotary axis, the stock we set up. Make sure it has front in orange in the front of the part and a mustard color in the back. Otherwise, you've got your model orientation incorrect, and you need to review the rotary pocket video to get the orientation for a vertical mill instead of a lathe. Okay, so I don't want to machine all of this material. I don't want to come down and hit this little piece here that needs to be turned. So what we're going to do is we're going to limit bracket where our machining is. It's in between the orange and the mustard color. So we do want to go from stock front, that's fine, but we don't want to go straight the model back. We're going to do a selection and pick this edge here. And that'll force the machining to stop at that rim. And hopefully it won't dive over the back of this. Now we have some other options here. Fixed tilt for cone machining. This is if you've got a 5th axis. You can tilt the rotary and do cones. Rest machining. It'll only machine what was left by the previous cutter. I don't generally use that too much because I found it gouges and makes some funny marks in places. So this is the default settings. It's the outermost of what's selected here. So right now that would be the stock OD. And then the inner radius is set to the innermost of what's here, and it's the stock ID. So what you could do is you could either select a feature, say, or you can go deselect the stock ID and it'll restrict the machining to nothing that's smaller than that diameter. Or if you wanted a particular point on the model, you could do selection and select an edge, okay, and it wouldn't go any deeper than that edge. And then you can do offsets from there as well. So that's what we're going to set it for. And then we're going to go to the passes tab. We've got your normal settings here. It looks like you can put step downs in, automatic step down to remove material. We're going to be using this rotary contour for a finishing op, so we're just going to leave that alone. The cutting move approach, we're going to allow it to go from the front limits because it can approach the part from that side without anything, but we don't want it to go beyond our back limit, which was this edge here, so we don't want to hit the chuck or anything. We're not leaving stock to lead, but you could use a progression of this tool to do roughing and then finishing. And then you can skip over gaps if you choose to, and exclude small areas. We're going to leave all those at default because I want to show you the standard way this works. Go to the linking tab. This is involving all your retracts, your lead-in radiuses, sweep angles, and I'm thankful it doesn't have any vertical lead-in radiuses, so but that's just me. Let's hit OK and see what we get here. Okay, so the rotary contour, it's giving us contour steps. They go in passes as it rotates, and it breaks that up into scallops. So if we take a look at this routine, this is what it looks like, minus the roughing that was done before this. So it really depends on the shape. You know, this might not be the results you're looking for. It looks like we left some islands here. Let's go back to our parameters and see what we can do different. Let's do a 10,000 step down. So we go to a linking tab. We're going to leave all this at default and we hit OK. Okay, so as you can see, it scallops this and rotates the part. Did miss a few areas that are close to flat. Maybe the ball cutter doesn't quite fit in those areas. So you'd have to come back and clean those up with a different command, or I've already cleaned them up with a prior command. All right, let's see what this does at simulate, see if it hurts my computer's head. All right, so this is what it looked like after the roughing, and here's our finishing. So it's spinning to do this outside wall. Now it's starting to move forward for the scallops. As you notice, this didn't cut any of the top flats at all. Okay, that is the demonstration for rotary contour. There are other parameters you could use to alter how it approaches these surfaces, but not every command hits everything the same way. So like many things, you have to use a combination of commands to fully clean this part up. And the different commands lend themselves to different types of surfaces. Okay, I hope that demonstration was fruitful for you. Now we're going to move on to our summary. In summary, this lesson focused on the Rotary Contour Multi-Axis CAM strategy in Fusion. It's a powerful tool for machining complex geometries on cylindrical or conical parts. The rotary contour strategy allows you to create precise toolpaths that follow the contour of your workpiece as it rotates, following a cylindrical axis, making it ideal for machining features such as intricate patterns on round surfaces. In conclusion, by the end of this lesson, you were able to apply Fusion Multi-Axis tab to apply the Rotary Contour CAM strategy to machine cylindrical shapes in 4 and 5 axis setups. You're able to model CAM and 5 axis CNC mill applications to industry standards and apply CAM and 5 axis CNC mill applications to industry standards. This concludes this lecture. I look forward to seeing you on the next one.